Good morning, students. Today we will discuss example based on previous three topics: three phase, star network, delta network, and power measurement. In previous three lectures we have already discussed about relationship between voltage and current in both the network, star network and delta network. We know that in star network line voltage equals to phase voltage and line current equals to phase current and line voltage equals to root 3 phase voltage. In delta network line current equals to root 3 phase current and line voltage and phase voltage are same. Okay, so keep in mind that relations for these examples. Okay, first of all, example 1, this is the definition. A delta connected balanced three-phase load is supplied from a 400 volt three-phase supply. Line current is given 20 ampere and power taken by load is 10 milliwatt. Find impedance of each branch and power factor of load. Okay, so first of all, this is delta network. Okay, 400 volt supply is given. Line current is given 20 ampere. Okay, first of all, this is delta network, so we know that in delta network line voltage and phase voltage are same and line current equals to root 3 phase current. So we have to find impedance, but for impedance we have to find this line current, phase current. Okay, so here line voltage equals to phase voltage, which is 400 volt, and we know that in delta network line current equals to root 3 phase current. So phase current, if we make subject phase current, so phase current IPH equals to IL upon root 3. So 20 by root 3 equals to 11.55 ampere. So this is phase current. Now we want to find impedance. So we know that impedance is nothing but Z equals to V by I. Here we find the impedance of phase. That's why we have considered both this phase voltage and phase current. So here phase voltage is given 400 and current, phase current is 11.25. That's why impedance ZPH equals to 34.63. Okay. Now we want to find other parameter is power factor. So what is power factor? We know that power factor is cos phi equals to R by Z. Okay. But here we know that power in delta network, total power in delta network is given by P equals to root 3 VL IL cos phi. Okay. So now make subject cos phi. So cos phi is equals to P upon root 3 VL IL. So total power is given is 10 millivolt. So 10 into 10 is to minus 3 and root 3 VL IL. What is VL? VL is 400 volt and IL is 20 ampere. So we have power factor cos phi equals to 0.72. Cos phi equals to 0.72. Okay. Simple example, you have to keep in mind the relations of voltage and current between phase and line. Okay. Next example is second example. A balanced star connected load of 4.3, this is the complex parameter, it is real part of impedance, and 3 is the imaginary part of the impedance. For phase is connected to a 3-phase 400 volt supply. So this is the example of star connected network. Previous example was delta connected network. So find line current, power factor and active power. Okay, so here we have not drawn the figure because the parameter is already given. Okay, you can draw the figure as star connected network, three phases. Okay, so here given data is, first of all, line voltage, three phase 400 volt supply, this is line voltage. Okay, now impedance is given, ZPH is equal to 4 plus J3. So this, we know that this is the rectangular form. So how can we convert the rectangular form into polar form? So under root 4 square plus 3 square equals to 5. 5 is the magnitude. And 36.86 is the phase. Tan inverse imaginary part upon real part. So tan inverse 3 by 4 equals to 36.86. Already we have discussed in classrooms how to convert that rectangular form into polar form. So now we can say that 5 is nothing but the magnitude of impedance and 36.86 is phase. Okay, so we have to find line current, power factor and active power. So first of all, in star network we know that line current and phase current are same, but here in star network, line current, line voltage equals to root 3 phase voltage. So we can find phase voltage VPH equals to VL by root 3. So VL is 400 and 400 by root 3 equals to 231 volt. So phase voltage equals to 231 volt. Line voltage is already given 400 volt. Now we know that relation as we have discussed in previous example, Z equals to V by I. So we can write that I equals to V by Z. Okay, so phase current IPH equals to VPH upon ZPH. Here VPH is already given, phase voltage 231, that we have find in above. 231 upon ZPH equals to 5. So 46.2 ampere. This is phase current. Okay, now we want to find line current, but we know that line current equals to phase current for star connected network. Okay, so here line current equals to IL equals to 46.2 ampere because these both the current are same in star connected network. Okay, now second parameter, cos power factor. So we know that power factor equals to cos phi. Cos phi equals to R by Z. Here we have, this is the resistive part of impedance. So 4 upon 5, already we have magnitude, this is 5. By comparing this impedance Z equals to R plus JXL. So 4 is nothing but the resistive part and 3 is XL. XL is the reactive part. So R plus JX, that if we compare this 4 plus J3 equals to R plus JX, then we have R equals to 4. This is the resistance of this phase winding and 3 is the reactance. So we have R equals to 4 and Z equals to 5 because impedance, value of impedance is 5 magnitude. So 4 by 5 equals to 0.8. So power factor equals to cos phi equals to 0.8. Now third parameter, active power. So what is active power? Active power is equals to total power V equals to root 3 VL IL cos phi. So we have both the parameters VL and IL. So what is VL? VL equals to 400 volt and IL equals to 46.2 and cos phi equals to 0.8, that we already found. Okay, so total power, active power equals to root 3 VL IL cos phi equals to 25.60 kilowatt. Okay, so these two are the examples on star network and delta network. You have to remember these all equations about line voltage, phase voltage, line current, phase current, power factor and total power is equal to root 3 VL IL cos phi. Okay, now we will see the next example. It is based on power measurement. We have discussed the theory of 2 wattmeter method. Okay, there are three methods to measure power: single wattmeter, 3 wattmeter, and 2 wattmeter. But important theory is 2 wattmeter method for power measurement in 3-phase supply system. Okay, so here this is the definition. 2 wattmeters connected to measure 3-phase power for star connected load. Keep in mind, 2 wattmeter method is for the star connected load. Okay, so connected loads read 10.37 kilovolt and 5.185 kilovolt. These two are the readings of wattmeter. These two wattmeters, W1 and W2. Okay, the line current is 10 ampere. Line current is given, it is 10 ampere. Calculate line voltage and phase voltage. So before moving on to this example, you have to read the theory about 2 wattmeter method. In 2 wattmeter method, we have find the phase phi by using this equation. It is very important equation for exam. Tan phi equals to root 3 W1 minus W2 upon W1 plus W2. So here we have to find line voltage and phase voltage. The given data is W1 is the reading of wattmeter 1 10.37 kilowatt, and second is reading of second wattmeter W2 is equal to 5.18 kilowatt, and line current IL equals to 10 ampere. Okay, so now first of all, this we know that in 2 wattmeter method, tan phi equals to root 3 W1 minus W2 upon W1 plus W2. Put that values of W1 and W2 in this equation. So 10.37 minus 5.185 upon 10.37 plus 5.185. So total tan phi equals to 0.57. Okay. Now phi equals to tan inverse 0.57. We have 30 degree. So phi is the phase is 30 degree. Now we know that power factor cos phi. What is cos phi? Cos phi equals to cos 30. Cos 30 equals to 0.86. Okay. Now we know that in 2 wattmeter method, total power is nothing but the addition of two readings of 2 wattmeters W1 and W2. So here total power P is equals to W1 plus W2 equals to 10.37 plus 5.185 equals to 15.55. Okay, but this total power is nothing but it is given by P equals to, we know that root 3 VL IL cos phi. Okay, so here subject this VL, so VL equals to P upon root 3 IL cos phi. So all the parameters are given. What is P? P is equal to 15.55 upon root 3 IL. What is IL? IL is given, line current is 10 ampere. Line current is 10 ampere. And cos phi, we have find that cos phi equals to 0.86. So VL equals to 1037 volt. This is line voltage. VL equals to 1037 volt. This is star network. We will discuss this method for star network. In star network, we know that line voltage equals to root 3 phase voltage. So here phase voltage VPH is equals to VL upon root 3. So VL upon root 3 is equals to VL upon root 3 equals to 1037 upon root 3 equals to 598.71 volt. So these two parameters, line voltage is equals to 1037 volt and phase voltage equals to 598.71 volt. So it is also important example based on this 2 wattmeter method. So first of all, you have to keep in mind the basic relation. This is the relation which we have derived in 2 wattmeter method. Tan phi equals to 3 W1 minus W2 upon W1 plus W2. From this we can find phi, and from phi this is power factor, and power factor is again in total power. By these three parameters we can find line voltage. Thank you.